Okay, so the first thing that I want to show you is how to wire up a basic resistive circuit. All right, we have a red line coming in from the positive of our power supply, which I'm just going to turn on over here. You can't see it, but it's over here. Then we have a black wire which represents the negative from our DC power supply. One of the most important things that you have to do as a student is to make sure that you understand the idea of AC and DC. These are our two different types of power sources. It's very important to understand what type of voltage you have in order for you to be able to take the proper measurements. So I'm going to wire up a simple resistive circuit. We're not going to put a switch in here. We're not going to do anything fancy. We're just going to run two simple wires from here to here. So we have from our positive through here, through our resistor, into our negative. All right, so if you wanted to follow the electron theory of flow, electrons would flow from here into this we'll call this an electrical junction, okay? Just for those industrial electricians out there, it'll act like our wire nut. It runs from here through here. Then it is tied to the resistor. From the resistor, electrons will flow through, back through here, through the positive, back to our power supply. Now we're going to set our power supply at around 12 volts, okay? Now the first thing I want to show is I want to take a basic voltage measurement. So, most important thing is I got to make sure that I'm hooked into the right leads to take my voltage measurements, which were over here on the left. Now, we're dealing with DC voltage. So, what I want to make sure I do is I take my function, I select it over to DC volts. This way I ensure that I'm taking a measurement that actually makes sense. Now, I have a range setting here that goes anywhere from 200 millivolts all the way to, looks like here, 1,000 volts. Now we're only dealing with the maximum voltage of 12 volts, so I'm going to turn this up to 20 volts. That 20 volts represents the highest value it can actually measure. So if I were to have 22 volts in here, well, I'm not going to get anything. I'll just get an overload signal. So we want to definitely avoid that. So what I want to do now is I want to take the voltage measurement from the power source. So I plug it into the same manifold here and here. Okay, these nice junctions. And right now I'm reading about 12.24 volts. Some of this equipment's a little old, so when it says exactly 12, we might want to adjust it down. Get it as close to 12 volts as we can. Now, this indicates that my power supply is supplying exactly 12.02 volts DC. Now, I want to take a measurement across my resistor. Now, in this type of circuit, I have only one load, okay? What that tells me is that all of my voltage is going to be dropped across this one resistor. The value of this resistor actually doesn't matter in this case when we're measuring just simple voltage. This voltage here will always be the same as the power supply. Again, as long as there's only one load in the circuit. If I put another resistor in there, I put a light bulb in there, all of those that rule goes away. The voltage drop will be different for each individual one, but it's definitely not going to be whatever the voltage power supply is. So, this is how we take a basic voltage measurement.